Hello students, this is video 7.9 and I'm going to just talk about some things that are coming up. Remember, your objective is I can earn 80% on the Unit 7 assessment at least. I excel skills, make sure they're done. You can do any extra 5. All right, for the next 14 days that we have left, and those include 5 days of Regents Review, this is what's important. May 20th is going to be your Unit 7 assessment. May 19th, Monday, tomorrow, will be a group assessment. Make sure you're ready for that. May 30th, the Flatland Extra Credit assignment is due. No exceptions. It must be turned in. Many of you who have low IXL skills need to do this assignment. Okay? June 3rd is going to be the Make Math exhibition from 5 to 6 p.m. You must attend. You cannot leave. June 9th through June 12th is Regents Review, specifically Regents Review. June 13th included, which is our last day of regular classes. And on June 20th, it is the Geometry Regents exam. Good luck. Let's look at the review. Okay, for part A, what you have to do is figure out what matches what. And I'm going to give you the actual term. Okay? So let's go. So number 1 says AC. So AC over here goes from a point on the circle to a point on the circle, and it goes to the center point. So that has to be a diameter. Line CD, here's line CD. This actually touches 2 points on the circle as well, but it doesn't go to the center point. And it actually goes through. So CD is a part of CE. So this is actually a secant line. Okay. Line segment AD. There we see it. It touches 2 points on the circle, but that's it. It's a segment. That has to be a chord. Angle AOB. So angle AOB. It touches the center of the circle, so it has to be a central angle. Angle CAD. CAD. You can see it's inside of the circle. It touches 1, 2, 3 points on the circle. This is an inscribed angle. Arc. Look at that. There's an arc there. So arc ADC. If you look at it, it covers half of the circle, so it must be a semicircle arc. Ray AE, so if you look at ray AE, it touches 1 point on the circle and it goes in the opposite direction. That is actually a tangent. Arc BC. Arc BC here, if we look at it, it's going to be smaller than a semicircle arc, and therefore must be a minor arc. OA, so line segment OA touches the center of the circle, touches a point on the circle, must be a radius. And finally, arc BDC is bigger than a semi and bigger than a minor, so it must be a major arc. Okay, so let's look at question number 11. All right, question number 11 says, if the radius is 5, what is the circumference? Well, circumference of a circle is 2 pi r. If r is 5, you're going to plug in 5 for r, and you will have 10 pi units. That's it. Or you could round it off to 31.42 units. Question number 12. So now we are looking at blue. Question number 12, and here it is. All right, it says, if circumference is 80, what is the diameter? Well, circumference is 80. What's the diameter? Start off with the formula C equals pi d. Plug in what you know, and then solve for D. D equals 25.46. And again, you can put units. Focusing on question number 13 here in red. This one is asking us for the length of arc AB. So thus the arc length. Remember, arc length is basically the ratio of the arc you have over 360 times its circumference. So plug in what you know. 250 over 360 times 2 pi, and then where'd the 14 come from? Oh, it's the radius given. That gives me my answer, which is 61.09 units. Again, just units. Last but not least, our fun question at the end was question number 14, which said, hey, there's this moon, and there's this orbiting lunar station. There's the orbiting lunar station. It's circling 32 kilometers above the lunar surface. Find the distance traveled by the lunar station. You probably guessed it's an arc length question. All right, so as you guessed it, it is the actual arc length. So here we're going to substitute in what we know. Arc length says I need the arc measure in degrees over 360 times the circumference, which is pi d. Let's plug in the things we know. So here I plugged in 360 because, again, it says it's making one orbit, which should be all the way around 360 degrees. And then I plugged in 245 plus 64, 2548, excuse me. is the actual diameter of the moon. But remember, the orbital lunar station is circling 32 kilometers. So that means 32 here and 32 here. So it's always circling an additional, that's right, 64. So you want to make sure you add that in, and then you multiply it by pi, and you're going to get 8,205.84 kilometers. That's a lot of kilometers traveled. All right, so here we go. Question number 15. So question number 15 is pretty straightforward. This is a tangent. Remember it up here, it says, assume that lines that appear to be tangent are tangent. When a tangent line hits a circle, it hits it at a 90-degree angle. So this is a 90-degree angle here. So that means this is a right triangle, and we can actually plug in what we know. This leg is 3. This leg is x. This is also 3 because it is a radius. So it has the same measurement as the other radius. If we plug it in and we solve for x, we're going to get 9.54 units. Remember, in order to get x here, you actually had to take the square root. So you would have taken the square root of x squared and the square root of 91, and that's how I got that solution. Number 16. If we look at this question, we have a chord and we have a line that is a radius, and we have an intersection here. All right, so this is actually a perpendicular bisector. So that means it cuts this into 2 equal pieces. Whatever this segment is the same as the length of this segment. So I have a right triangle here. I've got 5. I've got 3. I'm going to plug them in where they go. 3 is a leg. 5 is a hypotenuse. So I'm looking for x. Once I solve this, I'm going to get 4. And remember, if this is 4, so is this. They're looking for KL. KL is 8. Number 17. So this question takes you a little bit to think about. So if this arc here is 30, so is this arc. This one is 30 as well. Why, you ask? Because you have a chord that's a diameter intersecting another chord, making a right angle. Okay, so this arc is congruent to this arc. That also means, if we think about it, that we are looking at a specific type of triangle here. You see I've drawn an OP. OP is also a radius. The same as OK, and these two are going to be congruent to each other. Well, we need to know what measurement they are. Well, we know that AK is 8. That's right, because they told us that. So this is actually 8. This also is 8 too. So PK, the tall, long purple line, is also 16. So we have one measurement that's 16. You're wondering, where do I get the other ones? Well, think about angle measure. If you look at these two arcs here, they add up to 60. So that means this arc, or this angle, central angle, POK, is going to be 60 as well. That is the measure of this angle. And if we look over here at the angles that are left inside of this little triangle, so we focus on triangle OPA, again OPA, you will see that I've got a right angle and I've got this angle up here where the whole thing was 60, but we know this is a bisector, so we all know this is 30. 90 plus 30 is 120. This angle will have to be 60. The same thing is true for the other side, OAK. This would have to be 60. So you're talking about a 60, 60, 60. Hey, this must be an equilateral triangle. And with an equilateral triangle, all the sides are the same. So if this side here is 16, all the other ones are 16 as well. And that makes the radius equal to 16. And that makes this diameter, this one right here, equal to double, which would be 32. All right, so question number 18. Clearly we have two tangent lines and they intersect the circle. So these two segments of the tangent line are going to be congruent to each other. So we're going to set them equal to each other. Solve for x, and x equals 10. For question number 19, we have two chords, and we know that the chords are going to be, the product of the chords, the sections are going to be equivalent to each other. Therefore, we need to set up this equation, 4x equals 56, because that was 7 times 8. And then we're going to get x equals 14. The last one, number 20, I saw a lot of people kind of saying this is weird, and that's because we've got one secant, there it is, and then we've got one tangent line. So when we have a situation like this, what we want to do is we want to take the whole secant line, and we want to add it. We want to take x and 4. We want to add them together. We're going to take that quantity and we're going to multiply by the outside of the secant line, and that's going to be equal to the tangent line squared. See that? Tangent line squared. So this only happens, again, when you have a secant and a tangent. Okay? And then, again, you're going to go ahead and do algebra here. You're going to say 4 times x gives you 4x. 4 times 4 gives you 16, and it equals 169. And you're going to solve for x, and you're going to get 38.25. So quickly, just want to go back here and say this was when we had 2 chords. Okay, and then for number 18, we actually had 2 tangents. All right, let's take a look at question number 21. Question number 21 has a secant and it has a tangent. So now we're looking for actual angle measures. So what we want to do here is we want to look at the larger intercepted angle. Okay, so if we look at this angle here, that's created with the actual 2 lines that we have, or the line and the line here. I want to refer to the actual arcs that are intercepted. So the larger arc that's intercepted is 200 degrees, and that's because this is 100 and this is 60. So we know this has to be 200. The smaller one is 60. So in order to find the angle outside, it's going to be the larger minus the smaller. Okay? So the major, minor, subtract them, and you want to take 1/2, and you're going to get 70. All right? Question number 22 is really, really fun. You have to think about, well, I've got this regular hexagon, and a regular hexagon has 6 sides where all the angles are the same, all the sides are the same. So you want to figure out, well, what is the total amount of degrees inside of a regular hexagon of the interior angles? You're going to take 180, you're going to multiply it by n, and you're going to subtract 2. That will give you 4. So now what you end up with is 720 degrees. And you know that. That would be the total amount of degrees. So you're not done yet. Now I want to take this figure and I want to cut it into 6 equal pieces. And that's what I did here. So I'll go 1, 2, 3, 4, 5, 6. And what happens is these interior angles here, which happen to touch the center point of the circle, all end up being 60 degrees. And remember, we're looking for the arc length of HE. Here is HE, and here is an angle attached to HE. So since the central angle here is 60, that makes the arc measure 60 as well. And there I fixed it. All right, so question number 23. Pretty simple. You're given one of the radius. You know you have to draw on another radius here. You see you've got this perpendicular line here. This is going to be 7 because the whole thing was 12. You subtract 5, you get the 7. Use Pythagorean theorem, you should end up with radical 95, which simplifies to 9.75. All right, so the 3rd page of the packet you are going to skip because the video will be way too long and it's already massively long, and we will actually review that in class first thing, okay? But questions 33 through 45 are here, and I feel like the best way to answer these questions for me was to start off trying to figure out what the actual measurements of the arcs were, knowing that they total 360, okay? So you want to start off with the information that was given and that was really necessary, okay? GK is a tangent, which means that you've got a right angle there. It also says that DB is the diameter, which also means that you've got some semicircle arcs here and here. So once you find these measurements, and you can do that clearly, I'll do the first one for you. You've got this side here, so that will be arc, semicircle arc BAEFD if you want to use all those letters, okay? So you want to take 180, you want to subtract the ones you know, which are 56, 18, and 42, and you're going to be left with 64. Same thing over here, okay? The only difference is you need to mark down that this is a right angle. So that will actually help you understand that this is 180. And then you want to find the other 2 measurements, the 52 here and then what's remaining. So I feel like this was a lot more straightforward. I'm going to show you the solutions now. So for questions 33 through 45, you want to look and see if you got what I got, okay? And again, if there are questions you do want to ask me tomorrow. All right, we finally made it there to Secret Hot question. It says, what are the 2 images on the first screen? So the first screen from every Unit 7 video. And how are those related to the concepts learned from Unit 7? Remember to work on your IXL skills, the bonus ones. All right?